Hi, this is Hunter's reassessment on collisions. Okay, what we're doing here is we've got a collision between Superman and the eternal prison the Dark General Zod was in. So what we do is we set up Superman's mass, the velocity Superman's traveling in the X direction, the velocity that the prism's traveling in the Y direction, the mass of the prism. Then we set up mass of prism 1 and prism 2 after the collision. So we're going to set up our momentum formula to see first if momentum's conserved. Then we're going to see if kinetic energy is conserved. So we said both sides equal. Superman initial X plus prism initial X and plus Superman final X, Prism final X, Prism 2 final X. If you look down the bottom right, I have a little diagram showing Superman flying in, hitting the prism. He's traveling at 1,000 meters per second. He hits it. Superman continues flying straight, and the prism breaks into two and goes in different directions of unequal magnitude and angle. I just made these angles and magnitudes up. The only thing we're given in this is the angles and Superman's final velocity in the X direction. So what I do is I set it all up. I set the Superman and the prism up. Prism in the X direction is 0. So we don't have to worry about that. So we set it all equal to momentum of Superman initial. We do a little bit of formula and breaking it down and finding it out. Down the bottom right, you find out the X direction. And I find out the actual velocity for that by going 200 over cosine theta, because if you said cosine of theta is equal to 200, well x cosine of theta is equal to 200. If you divide out the cosine of theta, it'd be x is equal to 200 cosine of theta. So that's how I got those magnitudes. So we set all that up. I do a little bit of work on the x and y, and we find out that the x momentum is not equal to the initial x, and the initial final is not the same. And we do exactly the same with the y velocity. Let me go ahead and turn to the second page. This one, been working on it all night. It's real difficult working with 3 objects instead of 2. So what I did is, in order to get the velocities, I went ahead and squared both the velocities of the x and the y in the initial, and I squared the velocities of the x and the y in the final and got the square roots, and I got my velocities beginning and finals for both components. So then I went ahead and I had added all of them up on the previous page. Let me show you right here. On the previous page, I added all the x velocities up, all the y velocities, and that's how I came up with my x total, my y total, and then multiplied them by the masses. So then I went ahead and multiplied the 1/2 mv squared, so I got my masses times my velocity, and I got that number in joules right there. And then I did that for the final. I got that number. So in this collision, the momentum is definitely not conserved. Additionally, the kinetic energy is not conserved. it went to some other form of energy. Thank you.